All right, let's move on to the next concept within the hydrologic cycle. Something that's indirectly related to that is called a convection cell. This is an opportunity to teach this concept. So what I'm going to do is draw a little diagram here of two different surfaces, and what we have is land and water. We're going to talk about a convection cell, which is also the reason why the wind blows. One reason why the wind blows. And we're going to be talking about it on a local level. We're going to call these local winds. All right, we're going to be talking about whirlwinds in a little, but this is more localized. So, a convection cell is any time you have warm stuff rising and cool stuff sinking, you have a convection cell. You could talk about convection occurring in the mantle of the earth, where hot rock is rising and cool rock is sinking. You could talk about a convection cell within a lava lamp, where the hot wax is rising and the cool wax is sinking. Let's talk about a convection cell on Earth and how it relates on Earth's surfaces. So we have two Earth surfaces here. We have one land, and let's say that's the beach, and we have one water, and let's call that the sea. All right. Because those are two different surfaces, they're going to heat and cool differently. So on a hot sunny day with the sun beating down on those two surfaces, which one, sand or water, will heat faster? If you said the sand, you are absolutely correct. And you probably remembered being on the beach one time and you ran across the beach and your feet were burning and you had to quickly put on your flip-flops. And that's because the sand surface will heat up very quickly, and because of that the air above the sand will heat quickly. And knowing a little bit about convection, we know that heat rises, so the air above the land is going to rise in the daytime. Now, you're standing on the beach enjoying the day. Air begins to rise because it's being heated. You are not suffocating and dying. So, air must be being replaced from somewhere. That somewhere is the sea. All right, you can't have no air. Nobody suffocates and dies. So air is being replaced from the sea. Now, we talk about wind, where it's coming from. So if wind is coming from the sea, we're going to call this a sea breeze. Again, you can't have no air. It must be being replaced from somewhere, and that somewhere is from above. So if you stand and look back here, you have air rising above the land. It's being replaced from the ocean. You have a sea breeze. You also have a gigantic convection current on a local scale. All right, and I say local scale because you have to be near the beach to experience this. And if you've ever stood on the beach and you felt that breeze, you know what I'm talking about. Now, later on, the sun goes down. All right. And you go out to the beach, and you're standing on the beach, and you are barefoot now because the land has cooled off, but it's now the water has retained its heat and is now giving off that energy. You can't have an area where there's no air, so it gets replaced. This time it's getting replaced from the land. You can't have no air, so it gets replaced. It's getting replaced from above. So now you have another convection current. This time in the opposite direction. It's coming from the land, so we call this a land breeze. All right. So these are two types of localized wind that we're talking about in relation to convection current. In relation to the water cycle, let's say that the air temperature at the surface is 75 degrees. And the air above the water is rising. So liquid water is evaporating and it's rising with the air. So let's say it's gaseous water is rising with the air somewhere in the atmosphere. Now remember your atmospheric layers. In the troposphere, air is going to cool as it rises. Air cools as it rises. Now, water that was liquid and turned to a gas, all right, it evaporated. But at some point in the atmosphere, it's going to cool to what we call the dew point. All right, the dew point is a meteorological term, and it refers to the temperature at which condensation will occur. Now, that dew point and condensation means the water vapor will reach that level and condense. So what do you have? You have a cloud. All right, that's condensation. A cloud is liquid water droplets that's in the atmosphere, and that dew point is the temperature at which water will condense. All right, so that's why a lot of times you'll see a cloud with a flat base. That base is representing the dew point. All right, that's the level in the atmosphere where the temperature has cooled to the dew point. Sometimes that's very high in the sky if it's very dry out. Sometimes that's very low in the sky if it's very humid out. Sometimes the dew point is at the surface. And guess what you have? You have a foggy morning. All right, that's when the dew point is at the surface. Water is condensing from gas to liquid right around you, and you're standing in a cloud. All right, so that's where the water cycle comes into play when it comes to a convection cell. Let's take a look at some examples. All right, so here you go. Here's your sea breeze and your land breeze. And I didn't want to spoil you with a cloud above the water, so you can have clouds above the land. As long as there's water in the air and it's rising and meeting the dew point, you have a cloud. And this is a somewhat ugly cloud. Nevertheless, all right, the sea breeze and the land breeze, as it relates to a convection current, you could also have a different type of localized wind called a mountain breeze or a valley breeze. We talk about wind where it's coming from. So if it's coming from the mountain, we have a mountain breeze. If it's coming from the valley, we have a valley breeze. All right, now take a look here. During the daytime, you have two different surfaces. The mountain we're going to call rock. The valley we're going to call soil. Think about rock and think about soil as earth surfaces. Which one will heat quicker? If you're thinking rock, you're correct. And you can relate that to your asphalt driveway. It's the summertime, it's a nice sunny day, you run outside on your driveway in your bare feet, and your bare feet get burned. All right, rock heats up very quickly, but it cools quickly. So during the daytime, the air above the rock on the side of the mountain will rise. You can't have no air. It gets replaced from somewhere. That somewhere is the valley. So you have a giant convection current. Air is coming from the valley, so we call it a valley breeze. When the sun goes down, the rock heats quick, but it also cools quick. So now the valley soils are giving off its heat. So air above the valley is rising. You can't have no air. It gets replaced. You have a mountain breeze. All right, the air is coming from the mountain. Now, consider this mountain and valley breeze on a large scale. Let's say that this mountain is actually the Rocky Mountains, and let's call this valley the Great Plains. All right, what that means is this area where you constantly have a mountain and a valley breeze would be a perfect place to put a wind farm. So this is where we see our wind farms. We see them on mountain valley provinces, and we also see them onshore and offshore to take advantage of these localized type winds. So if you go out to Palm Springs, California, all right, that's right here. In between the mountains and the valleys, you'll see these big giant wind farms taking advantage of those localized winds. And if you go off the coast of, this one happens to be in New Jersey, if you go off the coast, you'll see these wind turbines placed just offshore a little bit to take advantage of the land and the sea breeze. It doesn't matter to the wind turbine whether it's a mountain breeze or a valley breeze. The turbines just want wind. So you'll see these things placed to take advantage of these two localized winds. Let's take a look at these wind types in a little bit of a different way. This is more of a regional wind, right, as opposed to a local wind that's localized to a coastline or a mountain valley province. This regional wind, and we're going to start here with the Santa Ana wind. It's more regional, meaning it stretches for a little bit farther of a region. It operates off the same premise. All right, this is a convection current type wind. The Santa Ana winds are notorious for fueling the California wildfires. So what you have here is a seasonal wind where the ocean has maintained its heat, the air above the ocean is rising, and it's being replaced from air from the land. All right, so you have this convection current. So what you have is this steady wind coming from the land, and all you need is a fire to start, and this breeze, what we're going to call a mountain breeze, but on a large scale it's called the Santa Ana wind. This is going to fuel any little bits of fires that start up in this very dry region. And in the lower left there you see these fires that are blowing out to the southwest due to the Santa Ana wind. This happens every year. It's seasonal, all right, and you want to equate the Santa Ana wind, this regional convection current, to the California wildfires. The California wildfires are a huge problem, pretty much because of the continued expansion of people into drier areas. Alright, let's take a look at a different type of regional wind that works again off of these convection currents. This type of regional wind is called the monsoon. Everybody has used that term. It's like a monsoon out there. Alright, so what you're referring to is actually the rainy season in Southeast Asia. Is a monsoon. Alright, I like this picture here because in Southeast Asia, the monsoon season is heavily dependent upon. These heavy rains will bring in fertile soil for agriculture. Alright, so these flooded regions here in the picture, which looks like a disaster, is actually necessary. Now, it's a headache here because you see the road infrastructure that has been submerged and actually cut off because of the flooding. Alright, and you see here that the development in the area is actually on the highland. Alright, however small that highland is. But this area around here has been flooded and can now be used for agriculture. Alright, soil quality is increased. Minerals have been replenished in a natural way. So the rainy season is very important to Southeast Asia. And here you go. It's a big, giant, regional, let's say, convection current. Alright, the rainy season occurs over the summertime when the land is heating up and you have air above the land rising. Alright, now what that does is air is replaced from the sea, right, from the Indian Ocean, and it's bringing a lot of water in because it was air that was sitting over water. And when that air rises, it cools and condenses, and you get your storms in your rainy season over land, right, in the summertime. In the wintertime, they don't call it the rainy season, even though it is raining, but it's just raining out into the ocean. All right, because it's in the wintertime, it's the water that has kept its heat, so it's the air above the water that is rising and then cooling and condensing and raining. The monsoon season in Southeast Asia is just a large regional scale convection current. It does cause problems and headaches in developed regions. Alright, so in the upper left you see people dealing with it, and the upper right again you see people dealing with it. It is a fact of reality in their society. Alright, people's days don't stop. They just deal with it. But in the bottom there you see where we usually use irrigation and the pumping of groundwater sources and the transfer of water from other areas to do just this, what nature does naturally in that region of the world. Alright, and that is to flood the surface and replenish soil. Take a break if you have to, but what I'm going to do is I'm going to move on to a new concept called the rain shadow effect. The rain shadow effect again applies to the hydrologic cycle and is an important topic both climatically and within the water cycle. With the rain shadow effect, what we're dealing with here is a situation where there's a mountain nearby a coastline. Alright, I might have switched from black to white on you there, but it's a little bit better to see it this way. So now the rain shadow effect is a nice topic to understand how topography might affect the climate of a region. So let's say we have air, a mass of air coming from left to right, and that air happens to have a lot of moisture in it. Alright, so we have an air mass and it has a lot of water vapor and it's coming in this direction. When that air meets a feature of topography like a mountain, it cannot go through the mountain, it cannot go under the mountain, it has to go over the mountain. Alright, whenever air rises, it will cool, because in the troposphere, temperature cools as you go up. Somewhere up here is the dew point. Alright, there's that concept again. As air reaches that dew point, that water vapor will condense and you'll get a cloud and it will rain. Alright, so on this side of the mountain, you're going to see a lot of plant life, you're going to see trees, you're going to see grasses, you're going to see the wildlife associated with that type of vegetation. Alright, now follow along. As the air comes onto the other side of the mountain and begins to descend, what's going to happen to the temperature of the air as it descends the mountain? If it cools as it goes up, it's going to actually warm as it goes down. So any liquid water is going to evaporate, because now warmer air can hold more moisture, and what you're going to have on this side is different vegetation. Alright, you're going to actually have cactus and very dry vegetation. So on one side you get rain and condensation, and on the other side you have very dry conditions and you actually have evaporation. And this is called the rain shadow effect. And what we've done here is we've drawn a picture of California. Alright, this is what California looks like. It's a region that's on the coastline, and just inland there's mountains, and on the one side of the mountain there's lush vegetation, and on the other side is Death Valley. Alright, so let's take this rain shadow effect and look at a couple places on Earth where this is happening. One of the more famous places is called the Atacama Desert in Chile and Peru. Alright, in South America, you see in the left-hand picture there, you see the yellow and the orange. The Atacama Desert is actually one of the driest deserts in the world due to the rain shadow effect. In South America, weather goes from east to west, and right here is the mountain chain. So on the east side of the mountain chain, you have lush vegetation and actually rainforest in here. And then as air descends on the other side of that mountain chain, the Andes Mountains, you have the driest desert in the world, the Atacama Desert. Known for something called the Nazca Lines, a very mysterious civilization that lived in this region. Not much is known about those people or why they made these very intricate symbols of monkeys and spiders and other things in the mountains along the coastline. Those of you who get into anthropology, you might study the Nazca people. Very interesting civilization. Alright, and here you go. Here's California. And just to show you the mountains that we're talking about here, Right here is Death Valley. So as air comes off of the ocean and rises over these mountains, you've actually set up two separate mountain chains. On one side it's very lush vegetation, and on the other side you have Death Valley, very dry conditions. I just threw this in here for you to be entertained. This is called racetrack playa. These are things that you can look into if you're interested. Racetrack playa has a very interesting mystery going on there. These rocks will actually slide across this dried up lake, and no one has actually ever witnessed one of the rocks moving. People have tried to figure out how they move, or what the mechanism is that moves these rocks. But what they'll do is they'll go out the day before and they'll measure where a rock is. They'll come back the next day and it will have moved, and no one ever has witnessed how they move. It's one of those mysteries at Racetrack Playa. Alright, and here's just an image to finish up the rain shadow effect. There's an island there where the rain shadow effect is affecting the climate of that small little tiny island there, where on one side it's lush vegetation, you can actually even see the clouds in the picture, and on the other side it's desert. Okay? And you can pause this. I found this and I thought there was good information here.